This video has to do with what we call projectile motion. So you're going to send, a rocket up into the sky, and what's the distance it's going to go up before it starts to come down. Or you're going to throw a ball up in the air. Ball goes up, ball comes down. It all has to do with gravity and how high off the ground the ball is, or the height of the ball. Okay, so they give us a formula in the problem. Genevieve is going to throw a rock from the top of a trail overlooking the ocean. So she's on this trail. Here's Genevieve. That's a hat. And she's going to throw the rock up, and then the rock's going to come down. Okay. When she throws the rock upward from 160 feet above the ocean, so this is the cliff she's on, 160 feet. And this kind of doesn't matter, but I'm trying to give you an idea of a picture of what's going on. The function, they give us the function, models the height of the rock above the ocean as a function of time, t. So the rock is going to be, right here when it's in her hand, it's going to be 160 feet above the ocean. Then it's going to go up. I don't know how high it's going to go up. Depends on how hard she throws it. It's going to peak, and then it's going to start coming down. So maybe it goes up to 120 feet above the ocean, and then eventually it comes down because of gravity. Okay, so that's what's going on, and that takes time. The rock goes up for so many seconds, and then it comes down for so many seconds. All right, the zeros of this function, which tell us when the rock will hit. We have to find the zeros of this function, which tell us when the rock will hit the ocean. Okay, so we want to know when does that function, I better write it down here, a negative 16t squared plus 48t plus 160, when does that equal 0? And that'll tell us when it's going to hit the ocean. All right. Now, it starts out with a negative number. I'm going to factor out a negative 16. I think 16 goes into all of them. And I get t squared minus, because I pulled out a negative, 3t minus 10. Now again, you don't need that negative 16. It's not going to affect the answer. We could divide both sides by negative 16 and just kind of get it out of the way. Or you can just factor with it there. Okay, so now I have t squared minus 3t minus 10 equals 0. This factors into t minus 5 and t plus 2. Yep. Okay, so now you might be getting quicker at this. You might notice that t could equal 5. You can write out the equations if you want to, or t could equal negative 2. Well, it's time. T is time. We're not going backwards in time, so take out the negative case. So it's going to take 5 seconds for the rock to hit the ocean. So that's what they wanted us to do on the first problem. So find the zeros, set it to 0. So I forgot her name, Genevieve. She's standing up there. She throws the rock up. She counts 1001, 1002 to 5 seconds, and at that point, the rock should be hitting the ocean. Okay, so B. Find when the rock will be 160 feet above the ocean. So take that function again. And when does that equal 160? Well, I can subtract 160 from both sides because I want to set it to 0. So I'm going to get, this one's kind of interesting. I'm getting negative 16t squared, that was a negative there, plus 48t equals 0. Well, how will we factor this? It's a quadratic equation. We're going to factor out the greatest common factor, which is negative 16t, and then t minus 3. All right, now this goes back to a video we did earlier. See how there's a variable right here with the t? You can divide both sides by negative 16, that's okay. But earlier I had said usually students just write this like negative 16t equals 0, but really it's just t equaling 0. So when Genevieve was standing on the cliff, you know, we had that picture, and she's holding that rock. No seconds have gone by because she hasn't thrown it up in the air yet. And she's already 160 feet above the ocean, so the rock is 160 feet. So when will the rock be 160 feet above the ocean? At 0 seconds. So 0 seconds. And we're going to get another answer because this binomial here, t minus 3 equals 0, you can probably see t is going to equal 3. So, and 3 seconds. So it's going to go up for a little while, it's going to max out, and then it's going to come right back on its way down to 160 feet, off the ground. So you can see it's the same height, like right here. And that's going to happen, ball goes up, or rock goes up, rock comes down. And it's going to take 3 seconds then for the rock to leave her hand and get back to the same spot of 160 feet above the ocean. Okay, so we got one more part. C, find the height of the rock at t equals 1.5 seconds. Okay, so part C, they tell us to find the height, and they're going to give us the time, 1.5. I'll put seconds here, but we know it's in seconds. So I have to remember the formula. H of t was negative 16t squared plus 48t plus 160. I'm hoping that's right. Let's look real quick. That looks right. Where's that function? There it is. Okay. So when they tell us the time and we're trying to figure out the height, we're just evaluating the function. Now I am not going to do that by hand, so I'm going to stop the video on my end for a little bit and then figure it out on my calculator and I'll come back. Okay, I'm back. So it takes a little while to type all that in the computer, but you can just, or in the calculator, you can just type that straight into a scientific calculator with a display and just put that in. I wouldn't do it by hand. Anyway, I got 196 feet. So if she's throwing the ball up, or the rock, she throws the rock up, after 1.5 seconds, it's reached a height of 196 feet.